Okay, we're back. Now, back here, it is the case. I was right about that because this is proven greater than this, any other line in between here will be greater than this. So this must be the least, because the same thing will happen on this side. I could be wrong about that, but I don't think so. I mean, maybe there's another way to do it more critically. Now this is easy, I made a mistake. This is where imagination helps in doing Euclid, because I didn't make that very imaginatively equal, but remember, this angle is equal to this angle. So here you have two triangles with this side being equal to this side, according to Mr. Smarty Pants, and this in common, and the angle is equal. And we know that when we have two triangles, with two sides being equal to two sides respectively, and the angle they contain are equal, the base is equal to the base. So here you have this, here's two triangles, okay? Two sides being equal to two sides respectively, and the angle they contain are equal, therefore the base is equal to the base, okay? This is equal to this, but this is also equal to this part, because they're both radii of the same circle. So if this equals this, and this equals this, this is equal to this. That is to say, this is equal to this, but this is also unequal to this because it's a part of it. It's less than it. So this line is both equal to this and not equal to this at the same time, in the same respect. That's a serious problem. So the thing that we granted, that this here is unequal to this, must be false. If it's false that they're unequal, it must be the case that they're equal. Okay, because remember, we said this is equal. Mr. Smarty Pants said no. Okay, well, they're unequal. This will let this one be greater. We cut from the greater the line equal to the lesser, and then we carried out the proposition, and we came to the conclusion, or the absurd conclusion, that this is both equal to this and unequal to this at the same time, in the same respect. Okay? So therefore, we have shown that if there be a circle and a point be taken outside the circle, and lines be dropped to the concave of the circumference, the line passing through the center is the greatest, and of the others, the more close to the center is always greater than the more remote. And of the lines in that same situation, point outside the circle, lines passing through the center, one passing through the center and not through the center, but now considering just as they fall in the convex of their circumference, the one between the 2 points that passes through the center is always going to be less, the shortest, the smallest, than the more remote. And of the others, the closer to the least is always going to be less than the more remote. And of those, of a line falling on the other side of the line that passes to the center, there will be a line that's equal to the other. And we've shown that. Oh, and I forgot to show this. And there cannot be a third one equal. This is equal. There can't be a second one equal. Can't have three lines equal. Can't have this, this, and this being equal. Because if they're all equal, then this is equal to this. Uh-oh, you have one more remote from the shortest being equal to the one closer to the shortest. But we showed that of those, the one closer to the shortest is always less than the more remote. So this is necessarily less than this. So here we have it being this equal to this and greater than this at the same time, the same respect, equality and inequality. So that can't happen. There can't be a third line. There can't be three lines equal. Only two falling on either side when you have those angles. Okay? So we have seen then that if there be a circle and a line taken outside that circle, of the lines falling on the concave of the circumference, the one passing through the center is the greatest. Of the ones, and then the ones closest to that is always going to be greater than the more remote from that greatest line. And of the lines falling on the convex of the circumference, the one passing eventually through the center is going to be the least. And of the others, the one closer to the least is always going to be less than the one more remote from the least. And of that two lines that are falling on either side equal, there can only be two equal when they have the same angle. And there cannot be three. So there will be one equal and only one equal to the one on the other side. Quod erat demonstrandum. Thank you. Bye.